Welcome to the lesson on perimeter and area of triangles. In this lesson, we will define perimeter and area and discuss how to use them to solve real-world problems. By definition, the perimeter of a figure is the distance around a figure, the distance, or rather the sum of all the side lengths. The area of a figure is the space that the figure takes up. So I have a triangle, sides A, B, and C. To get the perimeter, I would add the three sides, A plus B plus C. And in this case, I can apply algebra to this. So let's look at three problems where I know the perimeter and I'm looking for a missing side. In this first problem, the perimeter is 15. I know one side is 4. I know the other side is 6. And I know the third side is x. So if I add those up, 4 plus 6 plus x, I know they'll equal 15. 4 and 6 make 10 plus x plus 15. I subtract 10 from both sides, and my missing side was 5. And I was able to use algebra to do that. Let's do the next two problems. In this case, I know the perimeter is 11, and that both of those sides with the dashes are 3. So 3 plus x equals 11. So 6 plus x equals 11, and x equals 5. In the last problem, there's an algebraic expression for all three sides. So 28 equals x plus 2x plus x plus 8. If I can combine all the x's on one side, I'll have 28 plus 4x plus 8. Subtract 8 from both sides, and I get 20 equals 4x. And divide both sides by 4, and my x equals 5. So I can then go back in, plug in the 5, if I wanted to know the length of each individual side. Area, by contrast, as we mentioned, was the space a figure takes up. With a triangle, the two important measurements to consider are height and base. Essentially, those two give me the two dimensions that I must know of this triangle. But it's also very important to consider that every triangle we know about is half of a quadrilateral. A lot of times it's half of a rectangle. Well, a rectangle's formula for area would be length times width, and instead of using length times width, we'll use base times height and multiply it by 1/2. 1/2 times base times height will give me the area of any triangle. Let's take a look at a different looking triangle. Again, I have the base along the bottom, the height right there in the middle, and as I illustrate, even this triangle can be drawn to demonstrate that it is half of a rectangle with the same base and the same height. To practice this a little bit, let's look at a triangle where we have all the measurements we need and more. This triangle has sides 8, 7, and 10, and a height of 6. So what will I use in order to find its area? Well, I'll start off by saying 1/2. I'm going to use the base 10, and then use the height 6, that number in the middle. So 1/2 times 10 times 6 is going to give me 30. Didn't need the 8 or the 7 at all. But why? How do I know what numbers to use? Well, it's important to note that the base and the height of every triangle, regardless of how that triangle is drawn or how it looks, these two measurements, base and height, will always have a 90-degree angle between them. And you'll usually see that 90-degree angle as demonstrated by a special box. Now let's take a look at a few problems that will help us apply principles of area of triangles. My first practice problem gives me a right-angled triangle with sides 10, 24, and 26. Again, even though I know all three sides, I only need the 10 and the 24. So 10 times 24 times 1/2, which is another way to write our formula. 24 times 10 will give me 240 times 1/2 will give me a final answer, an area of 120. Look at another problem where I already know the area, I know the height, but I'm missing the base. So I'll refer to it as x. So 60 equals 1/2 times 15 times x. First thing I can do with this problem is multiply both sides by 2 to get rid of the 1/2. So 120 equals 15x. Divide both sides by 15, and my x equals 8. In the last problem, I look at a rectangle where I already know the area of 400, but I don't know either side, x and y. They're two different measurements. So I'm thinking what the perimeter of this rectangle could be, assuming that the area is 400. Well, there are several possibilities, but what comes to mind immediately is that 10 and 40, when multiplied, give me 400. So if I say that x is 10 and y is 40, 10 plus 10 plus 40 plus 40 will then give me 100. So a possible perimeter is 100. Even though there's other ways to solve it and other solutions, this will at least help me find one of them. A strong connection with this, of course, refers to mapping and gridding and how triangles are some of the simplest figures.